I suppose how I got into plant breeding was somewhat indirect. My father was a naturalist, and when I went to college, I became a biologist. And then you had to choose whether you wanted to be a zoologist or a plant person. And I chose the plant side because I didn't want to be a vet and I didn't like cutting things up. Then through college, I really sort of found an affinity for plant pathology, and I was fortunate enough to be offered a PhD position at Cambridge, where I was. And I started working on a group of diseases called downy mildews, and it was downy mildew of lettuce. And then towards the end of that time, I really didn't have an idea what I was going to do next. But an Indian professor passed through the lab, and I thought, hey, it was still the tail end of the 60s, the 70s. I thought, India, that'd be cool. So I got a fellowship to go out and work on tropical downy mildews. And I was out there for nearly 6 months. And then when I was in India, I saw this job in California. And I thought, California, that'd be cool too. So I applied for it, and the idea was I was going to come out here and I was going to do surf. No one told me the water was cold up here, but they gave me the job, and I've been here ever since. In those days, you couldn't transform plants. There was no DNA sequencing. When we were analyzing variation, we were working with starch gels and isozymes. We ran the first DNA southerns before they were even called southerns. And then we've worked through every sort of molecular marker system. So we've been able to characterize genetic variation with ever-increasing granularity. So it's been increasingly informative. So much of my career has been deploying state-of-the-art analytical techniques to characterize genetic variation. And what's great now in today's world with genome editing, we can actually do something about that genetic variation. The temperature is going up, water is getting more scarce, crops are moving. Crops are now being grown in Northern California that were in Southern California. Crops that were in Northern California are now being grown in Oregon. Things are moving up. But you have to have somewhere to go. And what we need to be able to do is to get crops in that region more tolerant of high heat or higher salinity or more efficient use of water because there isn't so much to go around. So you would obviously like to provide more food for less inputs. And the other thing is the world is changing. So how do we maintain even the current yields in a changing environment? And the two things obviously go hand in hand. Over the years, the yields in crops, particularly in things like corn, rice, wheat, it's been incredibly impressive. There's certainly a major contribution from plant breeding. And then going along with that, there have been technical advances of harvesting, post-harvest and things like this. But the foundation has been the genetic improvement. But that then, with a changing environment, we can't be passive. We can't say, okay, job done. So with the global population increasing, we need to increase yield. So we need to up the amount of food produced per hectare. But then you've got the situation we're getting limited in water. Nitrogen fertilizers are very expensive and environmentally challenging to produce. So what we need to be able to do is to make crops more efficient of the resources we're putting in there.